All right, this is day 4 in the Angela Yu Udemy course. Let's get to it. We have to make tic-tac-toe, tic-tac, paper, scissors, rock, paper, scissors game. Let's check out the demo real quick, which looks like this, or not. So here's the demo. What do you choose? You type 0, 1, or 2 for rock, paper, scissors, respectively. If I type 0, for example, that means I chose rock. So we see the ASCII art of a hand in the form of a rock, and then we see the computer's choice as well as an ASCII version of its hand, and then we see the result, which it's a draw, and then it ends. That's it. There's no like prompting the user to quit or play again. It's just one round and done. So here's the boilerplate. We got the three different pieces of ASCII art: paper, scissors, rock. Okay. So going by the so I tried to do this earlier and I was doing like a while loop where it's like, press 0, 1, 0, 1 or 2, press Q to quit. And then I was trying to, do like some clever math. It's like if rock is, if I put rock, paper, scissors inside a list, and I was like, so we got rock, paper, scissors, right? These are holding the ASCII art, each of these variables, right? And I was like, oh, well, if I go by index, right? And it's like if the index of the player's choice is larger than is smaller than the index of the computer's choice, then the player loses, right? Like if the player chose index 1, which corresponds to paper, computer chose index 2, which corresponds to scissors, then, player loses. Similarly, if player chooses 0, which is rock, and computer chooses 2, which is paper, player loses. If the indexes of the players and the computer's choice are equal, well, then obviously they have a draw. Otherwise, if the player's choice is greater than the computer's choice, the player wins. But of course, that messes us up because what if the player chose scissors, right? And the computer chooses rock, right? Then it gets all messed up. Then you got to start doing edge cases and accounting for all of that with nested if statements, which is probably not not that complicated itself. But then I got like spent a good time in it, a good deal of time in it, and I was like, okay, you know what? Let me just let me not allow my ambition to run ahead of my technical skills. So I'm just going to code it case by case. We have three choices, so 3 times 2 times 1. We have 6 possible outcomes, right? So we're just going to do it like that. All right. So I'm going to put the choices in a list here: rock, paper, scissors, right? And since this is just going to be one single round, right? It's going to start with a prompt. We're just going to name it prompt for now. And we're going to say, what do you choose? I'm just gonna, 0 for rock and 1 for paper, 2 for scissors. All right. So these are the choices. The user is going to input um, a choice that's going to be an integer. And then we're going to check that with what the computer chose for this stuff. So what does the program need to know at this point? So the program needs to know the user's input, which it will get. Then what is it going to do with that input? It needs to compare it to what the computer chose. So we're going to say, let's call this player choice, call this computer choice. Now the computer is going to choose randomly um, between 0, 1, and 3. So I've already imported random up here. So random between 0 and 2. Where 0, of course, is rock, right? 1 is paper, and 2 is scissors. So once the program has these two things, it needs to compare them. So let's say, for example, we're just going to go case by case, right? So the user did rock, and the computer did paper, or the user did rock, and the computer did scissors. There's two cases. And then we repeat it again. User did paper, computer did rock, user did paper, computer did scissors. And user did scissors, yeah. Okay. So if player choice equals 0, and computer choice equals 0. So the first case is rock, rock. Right, it's going to be rock, 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 paper, rock, scissors. And the other permutations are going to be similar. So the computer chose 0, player got 0, rock, computer chose rock, right? Print, just going to print draw, right? And then we just elif the heck out of this. So the computer chose 0 and the computer chose 1. So you chose rock, computer chose paper, lose. And if you chose rock, computer chose scissors, win. Is that how the game is played? Jeez, bro. 0, 1. So you got rock, computer got paper, computer wins, right? So we lose. We got rock, computer got scissors, right? We got rock, computer got scissors. Rock smashes scissors, so we win. Jeez. Okay, and this should have been elif, right? Okay, so for now, we just put some space here. Okay, so the other cases are that the user chose 1, computer chose 0, user chose 1, computer chose 1, user chose 1, computer chose 0, user chose 2. We're going to fix the outcomes in a second. So if you choose 1 and the computer chooses 0, so if you choose paper, computer versus rock, then you win, draw. And if you choose paper and the computer chooses oh, 0, 0, 0, 1, 0, 2, okay, 0, 0, 1, 0, 2, 0, 0, 0, 2. Okay, if you chose 1, so paper beats rock, you win. Paper, paper, draw. Paper, scissors beats paper, so you lose. And finally, if you choose scissors, computer chose rock, lose. If you chose scissors, computer, paper, you win. And it's a draw. So now I have three separate if statements. We could just do one single big if statement, right? And I know this isn't exactly elegant, but I think it should work. We still haven't used the actual ASCII art. I'm gonna do that in a second. So if I choose 0, we got nothing. Great. Why? So I chose 0. So this player choice came from input, gave us an integer that was a 0. Then the computer choice picked a random integer between 1 and 2. Okay, what are we doing wrong here? Let's look at this. Computer choice, right, gives us, yeah, integer between 0, 1, and 2. I know I can just give this to ChatGPT and ask it, but I don't want to. So if I do this here, right? Yeah, okay, well, nothing happens, but if I print this, right? Okay, we have this, and of course this is an integer. It, 2. Oh, input takes string. Input takes string. Python is comparing string and integer. Input takes string. Let's get rid of this. So we need to convert this to an integer. So I'll say 0, win, the, okay, play again, got to restart the program. 2, draw, right? Now what if I put like a 5? Nothing, right? So we could do else, I don't know, please make a valid choice. So if I say 5, right, please make a valid choice, we got to restart the program. I could put it in a loop now and all that, but yeah, so now let's go ahead and input the actual ASCII art. So um, player choice 0. In the demo, what did it look like? So you saw the choice. Oh, you see the ASCII art, right? You see the ASCII art, and this is computer chose, and then you see the ASCII art, and then you see, so this is your, uh, well, you see your input, just the ASCII art, and the computer chose, and then the outcome. So if player choice equals 0, so here we're gonna print, right? This is so ugly, man. Is there's probably like a single line, genius compression of all this logic that just solves it in 2 seconds. So print player choice. So if in this case player choice is 0, and we want the rock ASCII art, right? And this is going to be player choice. So that's going to give us, and then it says computer chose. And then we're going to do print ASCII art computer choice. What am I doing? Bro, what am I doing? So ASCII art, right? And we do the, and then computer choice. Yeah. Okay, so let's run this real quick. 0. Look at this. What do you choose? Blah, blah, blah. You chose 0. So we chose rock. Computer chose rock. That's a draw. Okay, that was only going to work if we both chose 0. Okay, now before we go ahead and put like a crap load of print statements, let's take all this. This is going to be the result. So we're going to take the ASCII art player choice, print computer chose. And could potentially do this. No. Well, we would have both of these would have to be 0, right? Put this here. So these are the cases where we choose rock. Result required to, oh yeah, obviously. All right. So we chose 0, that's favorite, computer chose that, that's a draw, let's do it again. Okay, so we chose paper, computer chose scissors. Does that make sense? Oh no, we chose rock. My bad. Rock rock, scissors. Yes, okay. All right. So this thing seems to work. Still ugly as hell. But I think at least it's gonna work. We can always refactor later. We could look back on this one day and be like, man, my genius had not yet been unlocked. Let's go here. So if I choose now two, that means I'm choosing scissors. So I chose scissors. Computer chose rock, so I lose. If I choose one, which is paper, chose paper. Computer chose rock, so I win. Great. Okay. Uh, okay. Just gonna do a quick like option to play again, and let's see now. I chose two, and got two is scissors. Computer chose rock, so I lost. Play again, yes. Oh, it reused, yeah. So it needs to prompt me again, right? So that means that the player choice and the computer choice need to be regenerated every single time. So they're going to go in here. Actually, I didn't even need to I didn't need to put these in a list, did I? And then like access them like that, right? I no, no, yeah, I did, because that is how I can use the choice to choose the corresponding ASCII art, I think. All right, let's try this now. Okay, let me clear this. So let's run this. So we're gonna choose scissors. I got scissors. Computer got rock, and I lost. Play again? Sure. Okay, and there we go. What do you choose? Could do like a little new line character here, right? So what do you choose? Zero for round. We're gonna choose scissors, and we win. Play again? Yes. Let's choose paper. So paper beats rock. Play again? Yes. Choose zero for rock. Now, if I put some nonsense, it's gonna say, please make a valid choice. So if I do like a nine, please make a valid choice. Play again? Yes. Okay, let's choose one for paper, and we win. Play again? No. All right. We could have put a message here, right? Like thanks for playing or whatever. So let's say 0. I got rock, computer got rock. That was a draw. Play again. Nope. Thanks for playing. Okay. So here it is. Man, it is ugly as hell. Let's see if GPT has any suggestions. I told it it's ugly AF, but it works. It's like it is ugly. But here's the important part. It is correctly ugly. Thanks, Ishmael. That's exactly where I should be on day 4. That's exactly where I should be, bro. Here, let's look at this together. Um, I prefer. Oh, look, he prefers it, guys. I prefer that you wrote it this way instead of trying to invent some clever one-liner. You're reading my thoughts now. You practice in expressing logic. Later, you learn how to reduce duplication. A few observations. Great idea, extract and result. This was the biggest improvement. Instead of writing these 9 times, right? 9 branches is fine today. You've essentially written the game's truth table. That's perfectly reasonable with the tools you have so far. There's one bug. This line, if I type hello or Q, your program crashes before it reaches. Please make a valid choice. Because int throws an exception first. Oh, okay. Um, I do not try except. So if I ran this, right, and I do banana, see, it never reaches this because this thing was an integer, so we get value error. So what was it? Try, accept. We just repeat this, right? And I think that's it. So now if I do banana, yeah, please make a valid choice. But then I get, oh yeah, because then it still continues on to this, right? So once it says please make a valid choice, it needs to go back to player choice. Yeah. So now what? Uh, all right. Yeah, I got it. What do I actually want the loop to do. Yeah. But do we put try except in its own loop or what? Inside the except block use continue, meaning sends the program back to the top of the, oh yeah, continue. So now if I say blah, please make a valid choice, boom. If I say nope, please make a valid choice, boom. If I say two, say one, for paper, I got paper, computer got rock, I win. Play again? No, thanks for playing. Out. All right, that is it for to die.